Hello, today we'll be discussing about linear functions. So linear functions describe a linear behavior, a linear relationship between a independent variable and a dependent variable. So we all know that linear functions are a straight line. So perhaps I want to draw it in the middle. Are a straight line. It describes a relationship of y and x. So over here, whatever x value that you give, it will give a corresponding y value. So more often than not, or rather always, x is your independent variable and y is your dependent variable. So just make short, independent. So how do we describe this behavior? We can describe this behavior or relationship with an equation. So y equals to mx plus c, and this might be familiar with many people because it's a very basic equation where m is the gradient. So over here, the gradient, basically the slope of the line. X is your independent variable, so x, and c is your y-intercept. So in this case, this would be my c, because this is where the y-intercept is, and then y is your dependent variable or your output. And this can also just be described as f of x equals to mx plus c. So how do we find all these things? All this gradient, this y-intercept, all of this stuff. Intercept. Alright, almost forgot how to spell intercept there. So firstly, we will just have to input values. So where would the y-intercept be? The y-intercept is at x equals 0. So you see that it's along this line. Y-intercept is x equals 0. So to find c, you will just have to input x. So this is 0 plus c, and you will get c. So that's one thing to remember. Input x equals 0 and you will find c. Next, how do we find the gradient? The gradient is just rise over run. Perhaps something you learned when you were much younger. Or y2 minus y1 over x2 minus x1. So we could take this point here, this point here. This would be my x1, my y1. This could be my x2, my y2. And that's how you find the gradient. And you just have to mix and match with this stuff. You just have to mix and match with these equations, and you'll be able to find all this stuff with the linear function. So linear functions are relatively easy. Very simple concept. So just another thing to know about linear functions is that there is such thing as linear functions without a gradient. So in this case, your linear function would just be x equals to whatever is here. So if this is 4, then it will be x equals 4. And in this one over here, so over here, this one, this would just be make it more clear. This would just be y equals to something. So if this is 2, then it will be y equals 2. Very simple. Now perhaps going through a question would be much easier to explain linear function, because right now we just kind of briefly went through everything, and these are all things which I believe are very simple. So it would be much better to just go through a question to really explain why it's a linear relationship, other than just saying it is a straight line. So we have a bicycle manufacturing company believes that in order to make a certain component to increase its range of products, $3,000 will need to spend on setup cost. So just from here, we know that to set up the company, it is the starting pay. This is where the money starts. So when we look at a function, we will already know that it will start on top. So perhaps it will start here, that it will start perhaps over here. We will know that it starts here. And each unit produced would cost an additional $5.75. So what this means is that every time a unit is produced, it will cost $5.75. So 1 unit, $5.75, 2 unit, $5.75 times 2. So just by seeing this, we already know that this is going to keep on continuing and continuing. And we can see that this behavior is something that can be plotted into a straight line, because we know that as it increases, it will increase the same. The gradient is the same. So we just have to look at the function, and we already know that the gradient is going to be the same. So just imagine that there's crossing the 3,000. Let's just imagine that it's crossing 3,000. All right. Okay. And just like that, without even realizing, you already did question D. Sketch a graph of the function. So remember to add 0. Remember to add maybe f of x and x over here. And there you have it. So this is your y-intercept. So now it says construct a function. We describe the total cost for producing components. This is very simple. This will mean that total cost equals to, so you set up plus 575 times unit, so number of unit perhaps. And we already can just change all of this to f of x. Setup is your c, this is your m, and this is your x. So 575 x plus, well, not c, plus 3,000. That's one question. Now find the cost of producing 500 components. So if you remember how to use a function, we just have to input f500 and there you have it. Just have to go into a calculator, times all of that, 5,875. So it would cost $5,875. Easy. How many components we produce on a budget of $9,000? So this is working your way backwards. So now we don't know what f of x equals. We know what f of x equals, but we don't know how much the input was. So 9,000 equals to 575 x plus 3,000. And this is just basic algebra. Just like that. So we'll bring it over here. Equals to 9,000 minus 3,000 over 5.75. So we actually get 1043 point something for 7, and we'll just take the lowest number. We take the lowest number because if you try to increase, if you try to take it, if you try to increase the number, you'll actually exceed the budget that was given. So maybe you say 5.75 times 1044 plus 3,000, you'll actually get this 9,300. So I was working calculator at the back my of the screen, so you wouldn't see, but you actually exceed. So always take the lowest number over here in this kind of case. So that's doing C, and we already did D. Very simple question once you start imagining the graph first. Just imagine when you start up, C, when you need to start, that will be your C. Not like this, not starting cost. When you start up a cost. So whenever the graph starts, it'll be 3. So it'll be C, I mean. So this might be confusing because we actually don't need this. And that would actually be doing question D properly. So we just get rid of that. And that's actually how you do question D. I hope it was helpful as perhaps a recap to linear functions.